Okay, welcome everybody. This is our weekly OPI lifecycle provisioning technical work group. We have a couple of items on the agenda today. We have new folks joining. Welcome. So let's start with a few things. Okay. We didn't discuss for quite some time, so I wanted to just to refresh and reiterate. We have Ada here contributing a few changes to our SMBIOS validation tool. So I want to spend several meetings discussing that. Let's start with that. So just a quick reminder. We voted and adopted DMI tables SMBIOS for standard and technology for having local access inside DPUs and APUs for inventory information. You can read about the SMBIOS spec on DMTF. And what I wanted to do is I wanted to create this repository which will help us parse the existing information from all the different DPU and APU vendors to make sure they are OPI compliant. And if not, it will help to raise exceptions so the DPU vendors can actually go and fix the unmatched tables and fields. So this is the main purpose of this repository. And Ada, I hope this is your name. I pronounce it correctly.
Yeah, perfect.
Yeah, so Ada was helping us contributing a few code to this repository, fixing a lot of errors. I guess, were you testing it on Intel IPU?
Yeah, I was. The main fix was for the testing because it used Google's internal Python packages, which weren't available outside of Google's VPN, I assume.
Excellent. So the Google packages, and the second fix, I guess, was, Google specifically asked for several Google specific things. So we added a couple of vendors actually to accommodate for different things here, right?
Yeah, the vendor name had to have the word Google in it. So we added a bunch of different vendor names.
Excellent. So the action item here is on DPU vendors. If you can take this tool after it is changes, run it on your DPU IPU, and maybe open issues here that can, provide us a little bit of insight how it looks like the run of this tool. What are the gaps that we're having, so we can start working on closing the gaps either inside this validation tool or inside the vendor's firmware that need to fix the implementation and stuff. Does that make any sense?
Definitely. And people could include DMI output if they want, because you can run this tool on DMI decode output. So if you're running into an issue, it'd be pretty easy just to upload the output, and then people can run it themselves if they want to.
Yeah, good idea. I think that we have some of the DMI decode outputs either in Slack or in email from different companies. Let me see who is here from. Okay, so I see Chetan from Marvell here. Go ahead, Chetan.
No, I think thanks, Ada, and we'll be happy to collaborate as well on this.
Yeah, I asked Chetan also, Chetan and Dash from Marvell to actually run this tool on the Marvell Octeon cards. They also produced the DMI decode output and also ran this tool. So Chetan, it will be extremely helpful again to run it again after the changes, see what output can we get, record it here, maybe as an issue. Raise pull request if you want to change anything, or work with Ada offline to make it work. Does it make sense?
Of course, thanks.
Okay.
Will do.
Vipin, I know that MD Pensando is not following the MIDI code yet. It's kind of a lot of implementation burden so far. That's still true. Any changes on that space?
No, I think it's just like we need to put manpower behind it to get it going. So far, we have not got into that.
Yeah, okay, thanks. But anyways, just wanted to bring this to the attention of the group. This is a tool that we're using. Eventually, we want to post the kind of matrix table of different DPU vendors and whether they pass or fail the validation tool results, so customers can actually see if there is something missing from the implementation that they need to be aware of. So this was topic number 1. Any comments before we jump into the next topic? Okay. Second topic is boot coordination. Pretty big topic. We have the initial boot sequencing markdown page here. Just to remind very quickly, we have the first use case, which is initial boot up, power up. Both DPU and host gets power at the same time. And then the boot process starts, and we feel that we need coordination between DPU, IPU, and the host itself. We discussed other use cases as well, so they're still relevant. We just decided to kind of deep dive on the first initial boot up approach. I added this line here that we started to deep dive on in-band versus out-of-band boot up coordination, and I created a separate markdown page for this use case of boot up initial coordination. And thanks to Lee Ballard, the action item from last week, this is a pull request to update the coordination. Basically, we discussed 2 things last time. We started with in-band PCI Express. And I guess the action item was on Reza, I guess, from HP, to kind of help maybe expand this subsection of in-band PCI Express with different options, why CSR, good option or bad option, different states, maybe just add a little bit more information. So Reza, I don't see any request. Yeah.
Yeah, I'm sorry. I added something just before this meeting, but maybe I don't know how to make it appear.
You committed it to your fork?
Yes.
So you need to, when you go to your fork, you can create a pull request between your fork and the OPI project, OPI provisioning lifecycle repository, and then you can propose a pull request.
Okay, I'll have to figure out how to do that. Okay.
Send me the link to your repository. I will show you really quickly.
Okay.
So while Reza is sharing the link, so I can help him, let's just quickly see what you can post in the chat, Reza. Let's see quickly the proposal from Lee on what we're doing today, I guess, in out-of-band with using platform BMC. This is a second approach. We're not saying which one is better. We just wanted to show 2 approaches so we can in-depth discuss 2 of them.
So just quick comment. I'm not aware that anybody's doing it today. I'm just saying this is a method.
Amen. Okay, sorry. Yeah. So yeah, Reza, once you click on this, you can click on this button, create pull request, and the pull request will be created for you.
Okay, let me do that.
So Lee, let's start with you, and then once Reza creates a pull request, we can go through that as well. Let's quickly go through what we see here on this page, and I guess the action item to all the participants of the subgroup: go and comment on Lee's pull request and Reza pull request once he has one. because my intention is once people feel comfortable with that, approve and merge them. Again, there is no decision here, just more deep dive on the different options in band versus out of band. Go ahead, Lee.
Yeah, so and this isn't complete, you know, like I probably want to do some more edits on this, but I thought I'd go ahead and put a work in progress in here. But so there are existing definitions for PLDM states, right? So we could create state sensors, and then PLDM would transport over SMBus, MTCP, SMBus, I2C, or pretty much every, you know, out of band protocol to the platform BMC, right? So anyway, you could create a state sensor here. The first part is like, okay, dealing with the termination, assuming this is the termination of an OS, right? But you could also have potentially, maybe you have different state sensors for critical services, right? But this looks more like the OS state, right? So a key one in here that I marked, and we should, you know, we can collaborate on which ones are most useful, but like graceful shutdown is pretty important, because you want to know that if your XPU is a PCIe adapter that's in a server, right, you want to make sure that it had an opportunity to gracefully shut down and that it's halted before you turn the power supplies off. You know, you don't want to necessarily corrupt the file system on the XPU. So
Which one is relevant, Lee, if we're talking about the initial boot up, the power on?
so that would be down, keep going. So I ordered them in the set ID number that, so there's a boot progress, which is state set 196, right? Okay. Now, I would say that there's still a gap here. Okay, so if you go kind of down to the bottom of this boot progress, right, you can see where you, let's see, what is it? State, yeah, 21, right? So you kind of exit out of here. I'm starting the OS operating system, right? And then, you know, how do I know where the what level the operating system's at, right? Because it's going to go through its run levels, right? So then it's going to get to a multi-user state, right? And then after that, there might be some critical services or daemons that I want to make sure are running. Like if I'm doing NVMe emulation, I want to make sure that that's running before, if I'm holding the server boot up into that time, right? So anyway, I put this down. This is like a starting point, right? We may have to come up with some custom extensions to PLDM state to get everything we want. But this gives you some insight into, you know, where the OS is, whether it's started to boot, crashed, it's stuck in UEFI, you know, these kind of things, right? Does that make sense?
Yeah, so we have had several hands raised. I think Dan was first and then Tim after Dan.
Yeah, so you mentioned here that we're not sort of approving this. We're just exploring different options, or
Yes, we're trying to see whether we can solve this problem in band using PCI Express methods that Reza is driving that direction. And I asked Lee to drive the direction. If in-band PCI Express cannot be resolved, how would we do it out of band? Once we have the deep dives onto this work stream, then we can discuss in this group, once we have all the details, and decide and vote on which is the best method, because I felt we cannot really decide until we have this a little bit more information deep dive on both of the methods proposed.
But don't we have to also back it up one more time to say, because this is using the platform BMC, and I don't think that's necessarily the only option here. So
Right.
The use case with
At the bottom, I put like if you were using the XPU BMC, right? You know, but I hadn't really filled that out yet. right?
Yeah, the use case that we're trying to solve currently, if DPU is inside the host and we want to do the coordination between the host and DPU, starting the platform BMC first. This is the first use case. I'm not saying the second use case of using the XPU BMC is not important. We just need to start somewhere. Make sense then?
Yeah, I would have started it in the other direction. I guess that's maybe I'm backing up to that decision is that you know, if this is an infrastructure device, then you know,
because
your platform BMC isn't necessarily the point of control.
I understand Intel desire to do so, but what we see from today's shipment, both Dell and HP and others shipping DPUs with the first use case in mind. So I think this is most important for us to solve because we already have a bunch of knowledge accumulated from that use case. Definitely the second that use case that you're mentioning is extremely important, but I felt it's easier to start with the first one.
Yeah, I think the other one's going to be a lot easier because it's you keep the platform and the IPU DPU you know, separate. You don't necessarily trust the two, and then the coordination happens at a higher level. So I mean, even you could take a lot of this text that you're presenting here, and it essentially is the same. It's just it's coming from the BMC on the card as opposed to the platform BMC. So I just
Your position is clear, Dan. We considered that and we decided to go with the first approach first. We're not dismissing the second one. We're just finishing the first one before we jump into second. Otherwise, we wouldn't make any progress. So well noted. Thank you. Yeah.
Okay, so and I guess that follows my second question is this theoretical what we're defining here, or is this from existing deployments?
We have existing deployments knowledge, and we try to see what we can leverage from existing, what we need to change, and then we want to come up with the best method available for us to actually solve this problem. Yeah.
Because it would be better if we were saying this is the problem that we have, and this is you know we want to standardize the solution.
Yeah, we said that here on this page. If you read this page, this is a problem statement, what we want to solve, and then this page is talking about how we propose to solve it. Yes, we have both of them. Yep.
Okay.
Tim, you have your hands up.
Yeah, I think the BMC on the DPU card is much more obvious how that would operate, right? So this is a harder problem. So my first question, when we say platform BMC, we mean the BMC on the motherboard of the server?
Yes.
Okay. I wanted to make sure that
Yeah, I want to suggest we use different terms because even in our internal discussions, we find that there's a lot of confusion with the term BMC. So we've started using the term AMC for what's been traditionally called the BMC on the XPU itself. So that's an add-in management controller. So we've got a add-in management controller, a baseboard management controller, and in some cases a chassis management controller. So just to differentiate their locations and their functionality. So that's a suggestion to maybe use a different term for the management controller on the XPU than the one on the motherboard.
Yeah, and it gets even
I'm
more.
okay having the table in this page for terms. Then we can put any acronym that we want and then explaining exactly what it means.
Yeah,
I'm
I only
okay
get
with-
confused when I think about an embedded system where maybe I have, you know, a main host server, but I also have DPUs and BMCs soldered down all on one board, and then it really gets confusing.
The platform BMC is a server BMC like we have today without DPUs.
And that term might be clear to all you guys. I'm not in the server space as much, so I wanted to be sure what that meant.
Okay.
And
Yeah.
then how,
We can clarify that's
and then
a
just
valid
looking through
point.
this state table, right? Most of these states are really referring to the BMC's relationship to the server's BIOS and operating system and not to a peripheral card. In fact, I don't see anything about managing the booting of a peripheral card. And maybe that's the gaps Lee is talking about.
Yeah, the boot progress, Lee, jump in, correct me if I'm wrong. The boot progress here is what DPU
Yeah.
sends to the platform or server BMC regarding its boot state and boot progress. So,
Right.
the server BMC can understand where exactly the DPU is in the boot process.
Tim, can you expand a little more on what you meant by the statement? I didn't follow you.
Yeah, maybe I just don't understand what I'm looking at, Joe.
The state here, again,
So-
the
so
state
how-
here
how is the-
represents the
how is the-
DPU.
Yeah,
Yeah.
how is the DPU communicating to the BMC on the host card, on the host? card?
PLDM. This
Through
is what we see.
PLDM state sensors.
PLDM state sensor. So DPU using PLDM over several options of physical connectivity, whether it's USB, I2C, or any other
I see. And
physical
but these-
interface. It
yeah.
will send this information, the state information, to the server or platform beams.
Okay. I'll stop asking questions for now. Thanks.
No, it's okay. Lee, I think this is all valid points. We just maybe need to put a little bit of text clarifying the direction, maybe even small diagram.
Yeah,
that
maybe
will
even a
show-
simple.
Yeah,
diagram.
I thought about putting a diagram in there.
Yeah.
I mean, so you probably even need a bit of a diagram that shows like, okay, you can think that the operating system running on the ARM cores, right, or the whatever cores they are inside the XPU, right? It's got to have registers that it writes there, and then there has to be either some microcontroller that implements, the systems management protocols, or there has to be something else, right? Or it has to be a what do you call that? ARM trust zone, or it'd have to be a privileged process, right?
Mhm.
That could, because when you're terminating or when you're crashing or whatever, that's pretty low level function from the point of view of the OS running on ARM, right? So really, there's not much capability for it to do much more than write to a register of some sort, right? And then you have to have something else that's going to convey that message. And then it feels like, unless you have an architecture where the DPU, XPU has independent power domain, you really need to kind of let the BMC know some things, the platform BMC know some things, or else he's going to have some timeouts probably, or something. Like if he can't talk, if the DPU doesn't give him any information, he's going to either proceed with boot, or he's going to go ahead and cut power. You need some coordination, right?
So Lee, if you don't mind, several action items on you. First of all is please add a small table with acronyms explaining what exactly platform BMC is and DPU BMC. Second of all, maybe a small diagram here that shows direction, that DPU actually sends this PLDM state information to the server or a platform BMC. And
Okay.
then I think maybe a few words here.
Yeah.
That
Does
will
that
help
diagram, maybe that diagram makes more sense? Well, I mean, I could put it here too, but also you may want to put it on the actual use case under the boot markdown thing, the top level page, right? Because it's really about the use case.
I agree. We have this diagram, just opened it right now, full components picture. So this has exactly the same naming. So we're following that convention so far. I have no problem changing it, but host CPU, platform BMC, DPU IPU, and the NIC BMC or DPU IPU BMC, all the different possible connectivities that we see deployed in the field. We see I2C, we see NCSI, we see PCI Express, we see serial, we see Ethernet. We see a lot of things. So I think this is helpful also to the story. So from the perspective that Lee showed on the pull request, I guess the DPU IPU main cores using the I2C bus, this arrow will communicate the MCTP information to the platform BMC. That I understanding that correctly, Lee?
Yeah, that was my thought. Yeah.
Okay. Thanks. Dan, you have a hand raised.
Yeah, I was just wondering, since we are talking about these two different models, and like Tim said, the other model might potentially be easier or more direct. Do we have something on the wiki already that says, hey, we have these two models, and you know, here's where you can look at what we're thinking about for model A and model B? Do we have that somewhere in the
No,
document?
not yet. We work in serially on two problems. Yeah, not yet.
Okay, I'm happy to volunteer to put something out there to be reviewed, as long as that makes sense for the group. Is just I think that would help this discussion as well. So it would make it clear that there are two approaches, and this is how we define this approach, and then you would go to this wiki to learn more about it, and then that would also give us a place to say, all right, well, if we did want to start to think about the other approach, you know, this is where you would go to learn more about it. Does that make sense? I'm happy to take that AR.
From my experience, I found this approach very disruptive and not focusing on the problem that we have in mind. This work group so far was very effective by having one problem and solving one thing at a time. So I really prefer us focusing on this use case, DPU and APU being a peripheral of the server, and we need to coordinate the boot between them, either in band or out of band. We already have a lot of, you know, grounds to cover in PCI Express and out of band with Platform BMC. So I prefer not to open any work stream on this. This is my opinion.
Not do more work, but just for someone to go and frame what you said earlier about, hey, we're going to do this approach first and then this approach second, just to have that written down in the.
Sure. I'll take an action item to do so. Yeah, no problem.
Okay, so you'll end up doing it. Okay,
Yeah.
cool. That would be very helpful, just to be able to define them both and say, you know, we've made the decision within the work group to focus on this one first, and then we'll work on the other one second.
Perfect. Yeah, that makes perfect sense. Thanks.
Thank you.
Hey, Dan, does it make sense to go ahead and submit a write-up on what you have in mind, and that way we have it queued?
I'm offering to do that, but I like Boris, I don't want to be a distraction.
Yeah, I understand. They're just saying we would, that way you have all your thoughts down and we just queue it up later.
Okay. Yeah, so if Boris writes the here's A and B, then yeah, I can sign up to write up B and just make sure that people understand that it's queued up behind A.
Perfect. Thank you. Okay, so Lee, I just want to finish this page. So PLDM state sensors over whatever physical bus, that I understand. Can you talk a little bit about PLDM RDE, I2C, and CSM, USB?
Yeah, I was going to flesh that out a little more. So, you know, RDE would be an alternative to doing PLDM state sensors. And then I'm assuming you would use like standard Redfish schemas for a host. So you'd then start trying to model the DPU as a host sensor. So, you know, I would start referring to the schemas inside of Redfish that you'd use for host management.
But on the high level, the proposal here is to do Redfish over PLDM kind of thing.
Yeah. So, I mean, RDE converts Redfish into a, you know, simplified, is it JSON format, I think. And basically what you do is you push all the work onto the end device, right? So that the platform BMC is kind of a pass through, right? There are some pluses and minuses to RDE, and the fact that, you know, what you end up with sometimes is all the differences that might be in the RDE implementation then show up all the way in the console, right? So ultimately somebody's going to manage this via Redfish, right? But if you have the device generating the Redfish, then sometimes there can be some implementation differences, and then the console has to deal with that. And then see what else. Also, it puts more work onto the, you know, it's generally seen as putting more work onto the the firmware, right? As opposed to PLDM is seen somewhat simpler, right? So anyway, it's two approaches. I mean, we run into two different approaches with NICs today, you know.
And we have a third one, which is NCS, right? NCSI.
NCSI OEM, yeah. What I was going to say there is currently there's no. So I mean, the reason I focused on the PLDM state set spec is there's an actual industry spec, right? That kind of defines what this is, right? So I haven't looked it up, but there's probably something equivalent with there is something equivalent with Redfish, right? There's NCSI would all be OEM commands. Even with NCSI 1.2 proposal, there really isn't anything that defines like OS states, right? So, or boot progress, right? So, you know, it would all be custom at this point. And then similarly, you know, like I2C is just kind of a lower level that would go under PLDM. So there's nothing really to do there, or USB. I mean, without a protocol that goes over them, you have to do something.
So I think that what will help is maybe under PLDM that you mentioned previously is to mention which physicals are can be used under PLDM, like I2C or USB. Also, with USB, I think we have an opportunity also to run Ethernet over USB between DPU and BMC, and
Right.
then we can do a lot of more complicated Ethernet stuff on top.
So the difference is as soon as you go from standard BMC to peripheral protocols into something that's TCP/IP based, then you're going to have to do trust establishment, right? You know, currently all of the DMTF protocols, the peripherals inherently trust the BMC, and there's no, I mean, you could add SPDM on top, right, to validate at least the device authenticity from a hardware or firmware point of view, but it's there's not credentials essentially that have to be exchanged. When you go into TCP/IP and you come up with some REST interface, then you're going to have some credentials. I mean, maybe you could base that in device ID certs, but you're going to have to, something else has to be defined, right? Because
and this is exactly the reason why I mention it, because it would be really nice to see all those comments that you just make now here on this page, like why this, why that, why a high-level protocol, the trust establishment, and stuff like that. So I think this will help a lot of clarifying.
So maybe add a table at the very beginning that kind of goes through the pros and cons, right?
Mm-hmm.
You know, why you might want to choose one or the other. I was using this kind of as a working page, right? Not just trying to put down what's available and then
I think it's excellent. Also, I believe in small iterations, so I have no problem what's this pass the linter of Markdown. I have no problem merging it like this, and then you can iterate on top of merged content instead of holding pull requests for like 3 months until we figure out all the small details. So I do believe that, you know, we need to merge it and then work on top of it as well. What I'm saying is it will be nice to see maybe at least an option here on top of USB to have a high-level protocol like TCP/IP and Redfish maybe on top. And SDPM with trust establishment is also a very interesting topic in this area. So.
Yep.
Okay. Any more questions to Lee before we jump to Rasa in-band PCI Express with CSRs and everything?
Yeah, I have a question for Lee in terms of, you know, one of the challenges that we are trying to solve with all of these suggestions is the fact that the ARM cores on the XPU is taking some time to boot. And when you're running PLDM or any of these sort of higher level protocols, is there an expectation that this is supported by the ARM cores, or this is supported by management controller on the XPU? What's the expectation there?
So, yeah, I mean, my experience is that every XPU is a snowflake. They're all different. So, you know, I would say that, you know, a management interface needs to come. So if you think of an XPU as a superset of a NIC, right? You know, then I would expect the management interface to be up really soon. Okay. And whether it's a standalone microcontroller that implements it, or if it's a what do you call that? A dedicated core in your ARM complex with, you know, trusted processes and all that stuff, right? Such that it boots quickly, right? You know, those are all implementation choices to vendors, right? But I would expect that, you know, well, so there's, and you know, okay, so like even all these things, if you have to integrate it with the platform, you know, especially if you're going to do things maybe even before you get full power, you know, if you have to regulate power and thermals, right, then it probably needs to happen pretty quickly.
And I'm assuming that there is an expectation that regardless of if it's handled by the ARM cores or handled by a management controller on the XPU, that the interface would be the same, right? That the platform BMC wouldn't have to know that difference.
Right. Yeah, I mean, you know, like if we go back to the diagrams we showed, right, there's basically just certain interfaces that go in between, right? And then in general, what's inside the different boxes is somewhat of a black box. There's just basically a contract that's on the interfaces.
I remember last week Reza mentioned, for example, that even I2C address is not standard across the DPU vendors. So, right, Reza? So
Yes.
maybe, yeah.
Right. So we would need some kind of probably there is, you know, somewhat of an ARP standard. I think it's kind of a de facto standard, right? And then we need to know, like, if we're going to use FRUs and stuff for inventory, or if we're going to use PLDM for FRU or whatever, you know, like there's probably some inventory thing that the BMC needs to know about, you know, just how much power do you need? What do you need for cooling, right? I mean, if you're assuming you're sticking this device into, you know, a server, it's going to need to know some things about the device, right? And then, you know, hopefully we go through all the pros and cons and we come up with one way of doing all of this boost synchronization, and that would be great, right? You know, so.
And to raise a point, I know it's a very small item, but if, for example, we need to standardize on a specific I2C address across the DPU vendors in the next generation, or if it's fixable in the firmware, I think this is a great platform in OPI to actually decide on this and standardize on this as well.
Yeah, I think it would be difficult if you try and think of all the different OEM vendors, right? Like, I'm not sure that Dell, HP, Lenovo, and Supermicro would all agree on what I2C addresses should be used for what.
Yep, that's clear.
Yeah, that's why we have standards bodies, right? Yeah.
Okay, anything else before we jump into?
Yeah, one quick thing. So Lee, you said you're not sure everyone would agree. Do you know the sticking points for not agreeing? I mean, could we enumerate the sticking points that as we know them, and get the rest of the member companies to also contribute? I don't want to discuss it here, just a question.
Now, I don't know what all the sticking points are. That there's another guy on our team, Jason Kilpatrick, who knows more about like but I think we're moving. So there are standards for discovering, what the ITC addresses are, and then setting things to a particular ITC address, which is probably the best way to go, right? And then things will tend to work, you will address 90% of the problems.
Gotcha. Okay, so I think it's something for a future, because I don't want to slow this call down. Cool.
But we need to flesh it out, Dave. So if you have this information, we can pull Jason in to maybe write a paragraph on this. It will be helpful.
Yeah.
Then you have a hand up.
Yeah, is this sort of standardizing a way that you can have a full processor complex with its own operating system on a card? And so this is not something that has been done before, and that's why we need to standardize it. Is that really the gist of it, for why we need these PLD commands and why we need to have a standard procedure for something like that?
I think it's because we've got multiple XPU vendors today that are implementing proprietary mechanisms for the cards to be discovered and booted in industry standard server. And we want to avoid, from a platform point of view, we don't want to curate a set of multiple different types of unique accesses to these XPUs.
I would say it may even be worse than that. I'm not sure that this problem has been solved in a generic fashion, right?
Yeah.
That you can stick, a XPU into a generic server and then these problems would work out. I think people have solved it in appliances, where they tightly integrated the different processor complexes together, but I'm not sure that it's been solved in a generic way yet.
All right, so opportunity, and I think this is a discussion point for the TSC. Do we want to try to take that on? So let's continue that part of the discussion in the TSC call on Thursday. I'll put it as an agenda item. Thanks, Lee.
And just to finish this topic, because we have so little amount of vendors, maybe 4 participating right now, maybe 5, 6, but not a huge amount. Maybe we don't need to solve the most generic cases for all the different cards and appliances, but only for DPUs and APUs. So maybe it's a lesser problem that we think. So.
Oh, right. So that's a good point. So maybe there's a lesser including problem we can tackle first, and then use that to bootstrap ourselves. Just, I agree. All right, let's drive on. I think we can, pick this up on Thursday, Jen.
That was sort of my thought around the question. It's sort of like, hey, if really the problem is just was said earlier that, like, hey, this card has cores on it that take time to boot. Like, if that's really the problem we want to go solve, then maybe that's a simpler, maybe that's an easier thing to go and broach as a standard versus like, hey, this is the standard for getting all IPUs, DPUs, and SmartNICs to work in a server, controlled by the platform BMC. There might be smaller problems to want to solve. Yeah.
Yeah, completely agree. So let's pick this up exactly where you left off on Thursday.
Excellent. So let's jump to Reza pull request. Reza, go ahead, walk us through what you have here.
Yeah, thanks, Boris. This is just the preliminary piece. They don't actually have the proposal in here, but I just wanted to make sure that we're all on the same page. So what I've listed is a set of use cases and assumptions. That is, and I'll just walk through these. Tell me if it's too boring, or we can just skip over them. So 1 or more XPUs in a single server, a single XPU attached to multiple CPUs within the same server. The XPU is powered on at the same time as the server BMC using auxiliary power. So that's a use case, right? Where the XPU is powered by aux power. Another use case is where the server BMC or the platform BMC controls when the XPU and the server processors are powered up. I think that's the most common use case today, where everything comes up when the user pushes the power button, whether virtually or physically. And then the XPU can boot from either the network or from its onboard non-volatile storage. And the XPU may have an add-in management card, an AMC. That's the new term we want to define. I'm not addressing the case for multi-host. That is where one or more XPUs are attached to multiple servers within an enclosure. That's a different use case, and I'm sort of drawing a boundary condition there. So any comments so far or questions?
Looks good to me.
Okay, thanks. We can move on to the assumptions. So the first assumption there is that when the XPU is powered by 3.3 volt aux only, the out-of-band communication from the server shall be limited to accessing the FRU or security trip only. That is, we're not expecting a whole lot of intelligence from the card. The power from 3.3 volt aux is very limited. I think it's 0.4 amps or something like that. So we cannot expect much, intelligent interaction with the XPU if that's the only power applied. And also, it should go without saying that there'll be no in-band communication from the server CPU when that's the case. Number two is that
Are you not, Reza, are you not expecting, or you actually prohibiting?
It's not expected. I'm not expecting, because if the XPU is only powered by 3.3 volt aux, it is highly unlikely that anything else in the server has power, right?
I think it's worth just clarifying that you're not expecting this to be, you're not actually prohibiting to do something more than that.
Okay, I can clarify that.
But doesn't that also imply that everything has a discrete FRU?
Everything.
Well, I mean that you're going to have a FRU, like, so. Anyway, I mean this is kind of a separate discussion, but supply chain being what it was, there's a lot of times when a particular FRU might be hard to get a hold of or things like that, and having FRUs was not necessarily the most fun thing. So
yeah, let me take a note of that. So you're saying the presence of a FRU is not guaranteed.
yeah, there are devices that don't have FRUs.
And yeah, so I think maybe okay. I took note. Yeah, thank you. We are aware that some XPUs today ignore the PE reset signal. So that's number two there. Number three is that some XPUs today have different reset mechanisms for the PCIe interface and the compute complex. So we want to be cognizant of that.
While that's true today, Reza, I just cautious about if we feel that P reset signal, for example, shouldn't be ignored. I think it's again in the scope of OPI to decide. So maybe on the next generation cards and not now, but
right.
Yeah. I would just differentiate and separate what we have today in our hands while what we can do potentially.
So you'll get I think you get a PE reset on a driver load. So if you handle that, then you might end up resetting the ARM cores when you're doing storage emulate. Like it could be a bad thing if you don't ignore it.
Okay.
Yeah, they're complex. That's what the number three is, right? There may be separate mechanisms required for the PCI interface and the compute complex. And that's what I'm struggling, but I state these assumptions so that, you know, when we come up with a solution, we can either prescribe the behavior and or prohibit certain behaviors.
Makes sense.
Number 4 there is that the XPU may start to boot as soon as it detects stable application 12 volts and 3.3 volts. Now, this plays back into number 2 about it ignoring the PE reset. In normal operation, the PCIe card waits for the PE reset signal, which is a signal on boot up. That signal sort of indicates, hey, your power is stable. But in the case where we're thinking about auxiliary power, then, you know, PE reset should be ignored because the platform is not going to send that signal in time. And you want the XPU to boot up with the auxiliary power. So, number 5 is the XPU is not aware of what it's being powered by, whether it's being powered by primary power or auxiliary power. So it doesn't have any ability to differentiate. So all of these things play together. Number 6 takes on a different trend. It's an assumption that the XPU has no dependencies on the status of the server OS or the platform OS.
Ted, you have some background noise.
Sorry.
Go ahead, Red.
Yeah. Number 7 is, and maybe we need some discussion and guidance on this, is that we're assuming that the XPU must be fully booted before UEFI hands over execution for the server OS to start booting.
And we need to define what fully means. Yep.
So is that a fair assumption, or does that need modifying?
That might need to be optional depending on whether, you know, well, obviously if you're not trying to boot from the DPU and if your platform supported hot plug or something like that, then you might, you know, be able to just have devices show up later because you're serializing at that point. And then also, are you going to wait indefinitely? The server never boots if the DPU doesn't complete booting. Like if it hangs, what do you do?
Right.
And you have a comment?
Yeah, it goes back to what I was saying before about the 2 different models. I feel like, you know, we had said that, you know, we're going to work on the XPU as a peripheral model first. And I think if it's a peripheral, then some of these like extra modes where it's sort of the non-peripheral mode where the device is its own entity, whatever it's then a lot of these things these assumptions are not true, right? Like if it's a peripheral, then a peripheral always needs to listen to the reset signal. It doesn't require any booting coordination with the server OS because it's a server OS peripheral. So I feel like that some clarification on the use case would make
It's
some
not happening today, then. I understand what you're trying to say, but today we already have shipping a lot of DPUs, and this is not happening on them. So what do we do with those cards? We ignore them, we fix them, we change the behavior. This is exactly the conversation we want to have. If DPU is peripheral of the server, today they misbehave. And this workstream trying to solve that by
Yeah, so my point is just when we define that use case of it's a peripheral first, then I think some of these assumptions change and get simpler. And so I think once we have that written up, then potentially some of these assumptions of essentially the device misbehaving or acting in the other mode, this might get a lot easier to define. So, you know, like the idea of like,
listen how then, because this is the shipping cards. If we want to change the behavior, we can, but we need to define what the behavior will look like, right? Saying that the device is in the peripheral mode is not doing anything to the device to make him behave as peripheral. We need to define what exactly that means, and then the devices vendors can actually implement that. But for example, if you take Intel IPU, right? If Intel IPU have this mode like UI peripheral, and it still ignores the reset signal, doesn't help us saying that it's a peripheral, right? We need to define the exact behavior of the peripheral in the server. Make sense?
Yeah, no, so the Intel IPU has two different modes. It has the I'm a peripheral, at which point it follows the reset signal, and then the other mode, which is I'm an emancipated my own thing. And in that case, it ignores reset. It does its own hot plug of stuff like that, and it's independent. So
unfortunately, other vendors didn't do that. So we have a difference that we need to figure out how we overcome it. Yeah.
Yeah. So I'm just saying, if we could define those two modes, then it would be easier for us vendors to be able to, if we set some expectations of like, all right, you're either in peripheral mode or you're not, you're your own thing, then I think that would be a lot easier to make these assumptions kind of line up in a more sensible fashion. Because some of these assumptions I would not have applied to the peripheral mode.
Tim, you have a hand.
Yeah, I would point out the use cases sort of defined what the assumptions apply to above. So that does help clarify it. And then also, Dan, I don't think there's just two. There's not just A and B. There's sort of the platforms in control mode where the DPU is peripheral. There's the DPUs in control, which is sort of a bare metal management, and it's managing the platform. And then there's sort of this third one where they sort of come up independently and do their own things and then establish communications and coordinate with each other. I think all three of those could be outlined. And we've talked about this in the boot sequence discussions, right? That there's these three different ways of managing booting, simultaneous independent and then dependent, but in each direction.
But if I understand what Dan is proposing, if we can maybe define across all the DPU vendors two modes and make the DPU vendors to implement two modes, then we can define the specific behavior as it is true versus untrue in those modes. I'm not sure we can do it, but if I understand them correctly, this is a direction that
I'm a little confused because
That's right, 2 or 3, however many there are. Yeah,
we carried the mode over from the previous conversation about whose BMC is controlling things. And this is even different. This is about boot sequencing after the BMCs have decided to let things boot, right?
Not necessarily, no.
Because I see on the use cases here, number 4, it says the server BMC controls the XPU. But in number 5, the XPU boots independently once the BMC on the server lets it.
It controls when the XPU gets powered.
Oh, okay. Right, so it doesn't manage the boot other than the boot can't happen until there's power.
Correct.
Okay, which kind of makes sense because it's the only controller of the master power supply, right? So that's
exactly
server BMC.
Ted, do you have a hand up?
Yeah, I'm a little concerned. I think irrespective of whether there's multiple servers in the mix, I think just having multiple DPUs in a single host is going to get very complicated with this method. And I think we need to work through exactly how we're going to, if we go down this path, exactly how the host is going to know when it's safe to boot, when it's got multiple DPUs sitting around on the bus.
But I'm not seeing a method yet. I see the use case and assumptions. I don't see any method yet. So what method are you referring to? There is no solution so far in this game.
No, just that the host is going to wait until the DPUs are booted. And for the host to know whether or not all the DPUs are booted means that it's going to have to determine which of the machines, which of the cards on its bus are actually DPUs that it should be waiting for. And that becomes a potentially challenging task for the BMC.
Yeah, I don't actually see that in this pull request though, Ted.
Okay, I see it
There's no
down here on
statements
the
about when the
assumptions.
host gets to boot.
Assumption 7, XPU should be fully booted before the BIOS hands over execution. Maybe I'm misinterpreting that.
Right. That's the one I opened up for discussion.
Yeah.
And so far, I see, I mean, there is obviously clarity that needs to be added to that statement. And so, yes, I think I can probably add some more clarity in terms of, someone mentioned timeout.
Well, Boris mentioned what is fully booted.
Right.
What does
Yeah.
fully booted mean? How does
Yeah.
the host detect it, and how do we manage multiple cards? And how do we manage a boot failure on the card? Which is
Yeah.
the timeout problem.
Okay, so in the interest of time, I think we'll conclude for today. This
Oh,
was
well.
excellent. Reza, I like this start, right? We can discuss several things and clarify them, but this is a good start. What I'm missing still is from you is the little bit deep dive on the in-band PCI Express. We talked about SRS, CRS on the on Slack and in the issues here. So maybe once we finish with that, assumptions and use cases, we can a little bit get more details on this.
Yes, I'm working on it. Yeah.
Okay, perfect. Thank you. And Lee, you have your action items as well. So thanks. So thank you everybody for joining today. This was good, and see you next week.
Thank you. Bye-bye.